Deeper than the Grand Canyon on Earth, a whopping 71% of our planet's landmass remains buried underwater. As a result, many magnificent geologic formations remain largely hidden from view. One such feature, which would become visible for all to be amazed at if the oceans vanished, is a spectacular canyon that is significantly deeper than the infamous Grand Canyon in Arizona. While the deepest point of the Grand Canyon is 6,093 feet or 1,857 meters deep, a structure known as Jemchug Canyon maxes out at a whopping 8,530 feet or 2,600 meters deep. This canyon can be found 890 miles west of the city of Anchorage in Alaska, where it lies within the frigid Bering Sea. There, the Jemchug Canyon is carved into more than 100 miles in length of the ocean floor, with its edifice being up to 15.4 miles wide, a bit less than the widest point in the Grand Canyon. And yet, Jemchug Canyon is believed to have entirely formed during the last 2.5 million years, despite the fact that Arizona's Grand Canyon, which is shallower, largely took a longer period of 6 million years to form. So, how exactly did this magnificent canyon come to be? To answer ice-aged this question, we need to go back in time to one of the Pleistocene's glacial maximums when the planet was at its coldest during a 100,000-year-long glacial interglacial cycle. At the time, 25% of our planet's land area was covered in thick ice sheets, a figure which vastly outnumbers the meager 10% today. Because so much of our planet's water was locked in ice sheets at the time on land, the global sea level was far lower, with this ancient shoreline starting at what is today 122 meters or 400 feet below sea level. Because of this, the area between the Bering Strait, lower sea level St. Lawrence Island, and about half of the modern Bering Sea was interconnected as a single landmass known as Beringia, which one could fairly easily traverse across. This contained many of the same large rivers Alaska holds today, except their extent continued far below the modern sea level. The largest of these was the Yukon River, which extended an additional 479 miles in length to a spot 60 miles north-northeast of the continental shelf referred to as the Eastern Bering Sea Shelf. As the ancient Yukon River continued flowing at a high rate, every year during the Ice Age it emplaced 24 million cubic meters of sediment, which is hypothetically enough to fill a square mile of land with 30.4 feet thick of sediment every single 365 days. While the actual area this turbidity current sediment accumulated at was much broader, across hundreds of thousands of years this sediment accumulated to such volumes that it destabilized edge regions of the continent.